Hello everyone, welcome to my class. I'm Dr. Ganesh from India. In this class, we are going to discuss about the data link layer services. We all know that the data link layer has been placed in between the network layer and the physical layer. So it has to provide the services to both the network and the physical layer. Either it may be in the OSI reference model or it may be a TCP IP protocol suite. Now in this class, we are going to talk about what are all the important services which is going to be taken care by the data link layer protocols. So first, we know that the data link layer main responsible is to move the data from one node to the another node. So the data link layer at the communication between from one node and the another node. Apart from that, the important function is the framing of information. So the data comes from the network layer. It has to make a frame by adding the header and trailer bits and to serving to that physical medium, and which is going to be control in that physical medium also. And the next function is error control and the flow control. These are all the major services of the data link layer. Now, these services, the first is in functions which includes the framing, flow and the error control. We all know that error control is going to be taken care by the error detection as well as the error corrections. Either it may be a single bit error or it may be a burst of error. If it is going to be a single bit is going to be changed while the data is moving from one node to the another node, it has to be detected first and then it has to be corrected. And the flow control is between one node to the another node, how much data it has to be pushed and how it has to get an acknowledgement. All these functions which has to be described in this services. So this is going to provide, which is going to explain about the procedures for the communication between any two adjacent nodes. So that it may be a connected in a connector or it may be a connectionless protocol also. In that case, how it has to communicate and what are all the procedure it has to follow. And then it doesn't bother about that what the link which is going to be. Either it may be a dedicated link or it may be a broadcast in nature. It doesn't bother about that because it has to provide the services for both the dedicated connections as well as it may be in that broadcast connections. And first we are going to discuss about what is mean by framing. It means that it is going to organizing the bits. For example, one node to the another node. So that two nodes may have a heterogeneous in nature or sometimes it may be in a homogeneous in nature. If it is going to be a homogeneous in nature, in that cases, if it is going to be connected via the guided medium, say for example coaxial cable, so all the data may be in the electric signals. So this is maybe a homogeneous, so it need not to convert in any other forms, just the data into a signals only which is going to be converted, that to be in that 0 to 5 volts of signals. Suppose the next node may be connected to the next further node via the unguided media. Either it may be a radio waves or it may be a microwaves. In that cases, then the physical state is going to be a completely different. So that is the reason this data link layer protocol has to provide the services for any kind of links which may be connected to that any kind of networks. So the framing which has to support for a physical layer. So the organization of the bits, how the bits has to be organized and it has to be forwarded to the next node. And the format for the physical layer. So as I mentioned, how the physical layer which has to support, so based on that these bits, these datas are going to be converted into signals that has to be accepted by the physical layer. Then we have to see that what is the major flow control and then error control, some of the protocols which is going to be used for the flow control in this class itself. Next is framing, to pack the bits into the frames. So how it has to accept by the physical layer, in that way it has to make it as a frames, and each frame is to be distinguishable. So the one frame has to be differentiated from the other frames. For example, if you take it over any postal system, say for example in the Indian postal system, if you want to post any of the letters from one place to the another place, there may be inside, there may be some messages are going to be there, and outer side you have to have an envelope that envelope which says that the from address as well as the to addresses. So both it has to contain, because the receiver has to know that the whom has this sent this message, so that he can able to give an acknowledgement also. So that is where it must have both the source and destination addresses. Now let us see that how the format of either it may be a source address or it may be the destination address. That address may contains his name and the street and the door number, and then which area it belongs to, what city it belongs to, what is a province and what is a state and what is a country. This is how the hierarchy system which is going to be there. The same way the frames also has to have that kind of addresses also. So the framing in a data link layer which separates a message to a source to a destination by adding that sender address and then destination address. So whenever it is going to make it as a frame, that frame must have both the source address as well as the destination address. So this destination addresses which is going to define where the packet has to go. So the destination address which will tells that this is what that next destination, and the sender address which is going to helps the recipient, so that the recipient once he receives a message, that device has to acknowledge to the recipient, so that the recipient can able to send the next messages or he can take next to further actions. So there are two types of protocols which has to be used in the data link layer. So that protocols are character oriented protocols and the bit oriented protocols. What it means for character oriented protocols: if the frame is going to be, all the data are going to be interpreted as a character, then the protocol which is called it as a character oriented protocol. If that all the data as well as the information which are all going to be interpreted by the bits, then that protocols which is called it as a bit oriented protocol. So mostly nowadays we are using it in the bit oriented protocols. Now let us see very important concept. This is a general frame format for any data link layer protocol. So which must have a flag which is going to have each and every protocol has to be identified with some flag patterns. For example, in HDLC protocol, it may be mentioned as a 0610. Then whichever the devices which is going to receive that any of the packet which says that the 0610, then automatically it understood that this packet, this frame belongs to that HDLC protocol. Then automatically it knows that what is the format of an HDLC protocol. So where the original data is going to be there, where the error and reduction and correction codes are going to be there. The same way the flag is going to be there, the same flag pattern which is going to be ended with that the same frame. So what is the use of that end of that packet or frame must have that same flag is? So it will tells to that receiver saying that it is an end of this packet or end of this frame. So that is where both the starting of the flag as well as the ending of that frame is also contains a flag. And then header must have an information about the source address, destination address, any other features. If we are going to add it to that our protocol, then automatically that overhead bits are going to be added along in the header field. And then the original data which is going to be have it in the received from the network layer. So this data, sometimes this original data that is depends on the protocol, either it may be a variable in numbers of characters. Say for example, whatever the flag, the same pattern may be repeated inside our original information. In that cases, in between the processing devices, it understood that if the same flag pattern is going to be repeated in that original data, then it understood that it is an end of that particular frame. To avoid that conflict, to avoid that confusion, so they want to do some one important process, that is what? Byte stuffing, byte unstuffing. It means that the same flag pattern, if it is going to repeated in the data, then it has to be changed. Here, this byte stuffing and byte unstuffing is going to be used in the character oriented protocol. And that flag pattern, if it is going to repeated in that original information, that has to be slightly modified based on that protocol procedure. At the same time, at the receiving side also, once it receives it, then it has to be unstuffed. And then in between, there are some escape bits also going to be there. In this escape bits, suppose if you are going to add the multiple packets or multiple frames in that same information, then it has to be indicated in that. This is how the byte stuffing and byte unstuffing is going to be there. And next very important concept is bit stuffing and bits unstuffing. So this is a character oriented protocol. The bit stuffing is going to be used. And this bit stuffing, for example, in HDLC protocol, it is a very famous concept. It means that all the data are going to be interpreted as in bits. So say for example, now you can see that the data from the upper layer. Now you can see that the data from the upper layer. And then flag pattern is HDLC protocol is 0, 6, 1s and 0. So whatever the frame which has to be started with that flag as well as which has to be ended with the same flag. So in between that information may contain 1500 bits. In that case, 1500 bits, there is a possibility the same 0, 6, 1, 0 may occur. In that cases, so in between the networking devices which may understood that it is an end of the frame. So we may lose that data, or else we may which will leads to wrong information, which may leads to unreliable communication. So that it has to retransmit. There are so many procedures. So while doing itself, it has to do the process to avoid such kind of conflict or the confusions. For that, the bit stuffing concept has been involved. Now you can see that the original information also contains 0, 0, 0 and 6 ones and then 0, 0 and then 5 ones and then 0. Similarly, it will goes on. So what will happen is after 3 zeros, after 5 or 5 ones are happen, then the next bit is going to be if it is going to be a 0, then the same flag pattern. If it is going to be a 1, there won't be any conflict. So in that cases, what they are going to do is 0, 6 ones. Once it have a 5 ones it comes, then immediately the next bit is which is going to insert one more bit that is going to be a 0, so that there is no possibility of flag pattern which is going to be repeated in that original data. So this is how the stuffing process is going to be followed in that. So what will happen after stuff that this data which is going to receive at the receiver end. So at the receiver end, when they want to retrieve that original information, so they have to unstuff it. So once it starts reading that information, first it has to see that flag, and after the flag, header information. After the header information, it starts reading and data. When it reads the data, whenever there is an 5 ones, when the next bit is going to be a 0, which was inserted by the sending station by means of stuffing in process. So that bit has to be removed. That is what we call it as an unstuffing of bit stuffing information. So this is how which is going to remove, and then which can able to retrieve an original information. This is what the bit stuffing at the sending side and unstuffing is an receiving side. This is an important concept in the data link layer services. Next is a flow control. How the flow control and error control which is going to be included in that data link layer services. In this flow control, there is one producer. It means that the sending node which is going to generate the data, which is going to generate the frames, and it is going to send it to an receiver side. And then whoever is going to receive the data, we assume it is going to be a consumer. Now you can see that the sending node which is going to push the frames into that consumer, which is going to receiving node. Say for example, the sender may able to generate a frames 100 frames per second. For each frame may be 1000 bytes. So, but at the receiver side may not able to receive. It is not capable of receiving 100 frames per second. It can able to accept only 50 frames per second. In that cases, what will happen? Without knowing that procedure, if the producer is sending notice, keep on sending a data, at some stage the frames may get lost. Because of that data loss which will happen, because of that, this producer has to producer will receive a negative acknowledgement and it has to resend. So to avoid that, we are going to use the flow control mechanism. In this, the consumer, the receiving node, which is going to tells to that the sending node saying that I can able to receive only the 50 frames per second. So there the sending node, the producer, can able to send only 50 frames per second, so that there won't be data loss can be avoided in this mechanism. So this is how the flow control mechanism which is going to be implemented in the data link layer. So next is an error control and the connections. We know that, as I said, there are two types of connections which is going to be linked from one node to the another node, that it may be a homogeneous or it may be heterogeneous. If it is going to be heterogeneous, there is a possibility for connection oriented as well as the connectionless. So both the possibilities are there. So these are all, we call it as an connections. And then when it comes under error control, so at the trailer ends, we are going to add the error control codes. So in general, very famous codes are the cyclic redundancy check, CRC check. So apart from that, there are so many mechanisms are available. So the first thing is that to detect an error, whether the error has been occurred or not, first to detect an error, and then once the detected an error, then we have to identify that which bit has been changed, which bit has been errored. So that bit is going to be corrected. So this is what an error correction mechanism. So error detection as well as the error correction mechanism. So there are different two types of errors are there. One is a single bit error, another one is a burst error. What it means for single bit error, what it means for burst error. The single bit error means if the entire information, there is only one bit has been changed from 0 to 1 or 1 to 0, it means that it is going to be a single bit error. If it is more than one bit is going to be error, then it is called it as an burst error. So error detection and correction mechanism also, how to detect an error, either it is going to be a single bit error or the burst error, and once the error has been detected, then what is the mechanism to correcting an error, that is also a process which is going to involve in the error control mechanism. So the data link layer, which is going to provide the services for framing, responsible for moving frames from one node to the another node, and error control and the flow control. These are all very important concepts. Now we can see the data link layer protocols. The data link layer protocol, which has to provide all the DLC services, as we mentioned, framing, flow control and error control. There are some of 4 important protocols. That protocols concepts are simple protocol, stop and wait protocol, go back again protocol, and selective repeat protocol. But very often we will be using it only 2 protocols in the data link layer. Now let us see how the simple and stop and wait protocol which is going to be operate. As a small gist, the simple protocol is which is going to use the very simple concepts to moving of frames from one node to the another node, and the stop and wait protocol, whenever any one frame is sent, once it gets an acknowledgement, then the next frame is going to be sent to the next node. And the go back in protocol, if keep on sending that frames from source station to the destination, one node to the next node. For example, if it is going to send a 20 frames, 1, 2, 3, 4, similarly it will keep on sending it. Suppose the receiver station, if it is going to send a negative acknowledgement stating that the 5th packet, then it will go back to that 5, and again from 5 onwards it keep on sending an data. So for that they will be using, there are so many mechanisms as like a sliding window mechanism kind of things that we will see in later. And then selective repeat protocol is if the source station is keep on sending in frames, so whichever the packets are, whichever the frames are errored or lost, only those selective packets, selective frames only retransmitted from the source to the destination. This is a selective repeat protocol. Now we can see that the finite state machine, which is going to explain that how this actions, how the protocol which is going to work from one node to the another node, data communication, we will see in detail. Here in this diagram, What is the state 1, state 2? It means that what are all the action which is going to take. For example, left hand side in that state 1. So it is a starting state of that. So once the data comes from the network layer, then it is going to take an action. There are some lot of events which has to be defined in that protocol. Event 1, action 2. So then it will move on to the stage 2. There are some actions are going to be there. If it doesn't work properly, then it has to send a feedback, or if it works properly also, which has to send a feedback to that stage. So this is how the finite state machine which is going to work, and this is the way we are going to explain all the protocol in detail now. Now let us see that simple protocol. Simple protocol is an receiver immediately handle the frame. It is assuming that the receiver is always ready to receive the frames, as well as it can able to immediately process it. That is where we consider that it is a very simple protocol. It is never be overwhelmed with incoming frames. So simply it will comes and it was going to do the process. Now let us explain with that process. In this diagram you can see that the sending node, the network and the data link layer. From the data comes from the network layer, the data link layer which is going to process it and which is going to send the frames to via the logical link. Either it may be a connection oriented or the connectionless. So at the receiver side, it's keep on receiving that frames from the sending node, and it will start doing the process, and which has to be escalated to that network layer. Now let us explain with some finite state machine diagram. So from the sending side, so the packet came from the network layer. So what is the major functions here in the data link layer? First it has to make a frame, and then it starts sending it. Once it make it frame, it keep on sending a frames to the receiver side. So at the receiver side, frame is once received, it means that they delivered the packet to the network layer. It will process and send it to the network layer. This is how the simple protocol which is going to work. But in practical, most of the times the simple protocol doesn't work, because it has to understand that what is the accepting capacity of the receiving node. After that only the sending node must send the data. So now let us move on to that, how it works in the reality. So from the network layer, the packet comes to a data link layer, and then data link layer do the process, make it framing, and then send a frame to the receiving node. Receiving node, data link layer, which is going to receive a data and then send it to an network layer. Likewise, the process which is going to be repeated. This is how the simple protocol which is going to work. Now let us see the stop and wait protocol, which is a highly reliable protocol. It uses both a flow and error control mechanism. It means that the flow control, first of all, which has to control the flow of data from the sending node to the receiving node. It will understand that what is the capacity of an receiver node, as well as which will receive an acknowledgement after that only, which is sending a next frame from the sending node to the receiving node. And the error control mechanism is, if any other frame is errored or lost, then immediately the message will comes to a negative acknowledgement will comes to an sending node, then the retransmission of the packets, retransmission of the frames which is going to happen. So the stop and wait protocol by default, which is going to use for both the flow and error control. It is going to use a sliding windows mechanism to regulate the process in a smoother way. It is going to use a sliding windows. In this sliding window, both the sending as well as the receiving station agree to some window mechanism. It means that it may agree to accept that 7 packets at a time. So beyond the 7 packets, if you are not getting any acknowledgement, then you have to wait for it. The sending station has to wait for it, or else there may be some timer mechanism which is going to be used. That I'm going to explain in this next slide. The sender sends 1 frame at a time and wait for an acknowledgement before sending the next one. So after getting an acknowledgement, successful or unsuccessful, then it will start sending a next frame. So to detect an error, it is going to use a cyclic redundancy check to each and every frame. Now we can see in this diagram, the sending node, it will get an data from the network layer, and in the data link layer, which is going to process it, there will be a timer which is going to synchronize the operations, and then the frames are generated, and that frame which contains a CRC, along with that it is going to send it to an receiving node. In the receiving node, it has to do a process. Now let me explain that. What is the use of that timer and how the functions which is going to be used in this with the help of finite state machine diagrams. So here you can see that the sending node process. The sending node, the packet came from the network layer. Once the packet came from the network layer, then it is going to make a frame, and another one processes which is going to make a copy of it, and then the frames which is going to be sent, and immediately the timer which is going to be started. So there will be a predefined time which has to be mentioned here. So the protocol itself they will mention. So maybe a double the round time can be given. So even after that, suppose if it is not getting any acknowledgement, then it understood that the packet may be lost or frame may be lost, then it has to retransmit the packet. So make a frame and save a copy and start a timer and send a frame. And there is two options, say for example 5 milliseconds or 5 seconds. After 5 seconds, if it doesn't get any acknowledgement, then immediately it will restart the timer and resend the same packet, resend the same frame. Or else within the time frame, if it is getting an acknowledgement, just which is going to discard it, stop the timer and discard whatever the saved frame which is going to be discarded also, and the next frames which is going to be transmitted. At the receiver side, the corrupted frame is received. For example, if the corrupted frame is received, then that corrupted frame will be discarded, and it doesn't give any reply, then automatically after the timer the sending station will send, or else it may send once it is received a proper message, then it will send an error-free frame is arrived. That way it can send a message so that the sending station can able to send the next frame. This is how the stop and wait protocol which is going to work. Now in this diagram you will understand that how the process which is going to be. Now when the packet comes from the network layer, then the data link layer make it as a frame, and first immediately the timer will start. It will send up frames to the receiving side. At the receiver side, the data link layer, once it receives, then immediately it will send an acknowledgement. At the same time, the packet will send to a network layer. So if that acknowledgement is within that duration of the timing, then it will start sending the next packet and retransmit. So when it is sending a frame, but in between, if it is going to be lost, second case, if it is going to be lost, then what will happen is, within the time duration, it can't able to get its acknowledgement. So what it understood is, on the way there may be some frame may get lost, so which is going to be resend. That is the second process. Then after the resend, the timer which is going to be timer is going to be reset. Then within the time period, if it is getting an acknowledgement, it is successful, then the next packet which is going to be transmitted. The third case is the receiver is sending an acknowledgement. That acknowledgement is lost, then immediately the sending station will understood that packet, the earlier frame which has to be lost, and that has to be retransmitted. This is how the stop and wait protocol which is going to work in this. Next very important concept is, there is a concept which we call it as a piggybacking concept. So whatever the example which has been explained here is, we consider that these are all going to be unidirectional. In this unidirectional, you can, just for an understanding purpose, in reality both the nodes can be able to send as well as receive an information. So here the piggybacking concept is the acknowledgement which has to be included in the along with the data. So that is what we call it as a piggybacking. For example, the sender is sending in data. At the receiver side, it is sending an acknowledgement. It means that if that receiver don't want to send any message, simply it send an acknowledgement. That is a normal data process. And the second case is, the sender is sending in data, but now the receiver wants to send the data, means then the receiver will send both data along with that. So whatever the data receiver wants to send to that sending station, along with the data, the acknowledgement which has to be sent along with your original information, so that we can reduce the number of packets travel between one node to the another node. This concept we call it as a piggybacking concept. I hope you understand the concept of data link layered services. So let me recap that. In this data link layer concepts, we have discussed about what are all the data link layer responsibilities and what are all the major functions responsible for moving a data from one node to the another node, and then framing, and then error control and flow control. And then we have discussed about how the error control and flow control, if it is working, and what is the use of that framing and how it is going to control the physical layer medium. And then we have discussed about the 4 important protocols, that is in a stop and wait protocol, simple protocol, go back and protocol, and selective repeat protocol. I hope you understand the concepts in the data link layered services. If you have any doubts, you please mention in my chat window. You please mention in the comment line. I'm happy to respond to your questions. If you don't subscribe to my channel, please subscribe to my channel. Thanks for watching. Thank you. Have a great day.